Now we're going to question 2 from paper 2019, paper 1, AQA chemistry. We're carrying on. I'm just doing the whole lot. Type of light mass spectrometry can be used to analyze large molecules such as pentapeptide, leucine, or encephalin. P is ionized by electrospray ionization and its mass spectrum is shown below. So we got 556 in here. So I already written down here the answer. It says yes. Describe the process electrospray ionization. Given equation represents P for this process. So I say P is ionized by firstly dissolving P in a solvent and pushed through a small nozzle at high pressure. A high voltage is applied to it, causing each particle to gain a H+ ion. The solvent is then removed, leaving a gas made of positive ions. Okay, so that's a complete answer. You can choose a simplified one if you want to, but you need to mention is dissolved in a solvent, is pushed through a nozzle, a small nozzle, a high pressure and a high voltage, and then produces, each particle gains an H+ ion. And the formula is if P plus proton gives you pH plus there. So that's the answer to that question. The second part is that what is the relative molecular mass of P? So we know that MZ shows a peak at 556 because you gain a proton, so it becomes 555 for that one there. Okay, so that gained the proton, so the molecular mass is 555. Okay, so now we're going to do question Q is ionized by electron impact at your mass spectrometer. So they give you Q plus ion as a kinetic energy of 2.09 times 10 minus 15. The ion takes 1.23 times 10 seconds to reach the detector. The length of the flight is this 1.5. Calculate the relative molecular mass of Q. So how I did this is like this. So you got this formula. So you need to rearrange that to find the mass. Okay, the mass is the molecular mass is in grams. Okay, in kilograms that you find, and they want it in grams. So first thing you do is hold on. So the first thing I did is I just worked that out already, is that you got two formulas. You got that, and you got the other formula, which is velocity equals to distance over time. Okay, so we know the distance and we know the time, so you can calculate V. So V equals to 1.5 divided, because I give you the meters, divided by time, which is 1.23 times 10 minus 5. So the answer to that is 1.22 times 10 to the 5 meters per second minus 1. Okay, so then you use this formula here, it rearranged to find M, because we need to work out V to put the V in there. Okay, otherwise you won't be able to work out M. So if you rearrange, work out M equals to 2Ke, because you got 2 times Ke, okay, divided by V squared. All right, so M equals to 2 times 2.09 times 10 minus 15 divided by 1.22 times 10 to the 5, all that squared, as it was just that. The mass is going to give you is 2.81, I think, times 10 minus 25 kilograms. Okay, so because you need to work out into so you got to work out that is in kilograms, so you times by 6.02 times 10^23. Okay, because you work out moles, times moles, usually you divide by that, don't you? So times by that, then you got mass equals to 0.169. Because that is already in kilograms, you need to show in grams, okay, because it goes from grams to kilograms. So you need to actually multiply this by 1,000, and that will give you the molecular mass in 169.2 grams per mole. Okay, so that's why you go. So you're just doing the wrong way, the other way around. You're going the opposite way. Instead of starting with doing this and then work out the other bit, you work out the other bit and you work out backwards this answer there. Okay, I hope that was helpful.